so we're getting going with 1.4 types of functions and their rates of change. We'll get to rates of change a little bit as we move on. But basically, we'll start off with one of the easier functions that you can think about is a line, a linear function. So what's the basic form of a linear function? What form is it in? Y equals mx plus b. So the easiest way to write a line is in this form, y equals mx plus b. And the m is the number in front of the x, and the m stands for the what of the line? Slope. And b stands for the what?
Y-intercept.
Y-intercept, where it crosses the y-axis. So if you know those two things, then you know a lot about the line, right? So just very simply, if I put y equals negative 5x plus 3, so again, if we just to give those, you can easily answer that by if I ask you for what the slope is or what the y-intercept is, you can give that. So what's the slope?
-5.
And what's the y-intercept?
3.
3. We got that. Okay. Now, what I always like to say, for me, there's two user-friendly things about the slope-intercept form. One is it's easy to get points. You just plug in your x, you can get your y's pretty easy. So one nice thing is easy to get points, to get your coordinates. The other thing I think is it's easy to graph. So I like to just go ahead and knock that out of the way now to show you how to graph it when it's in this form. Because technically I know where it crosses the y-axis and I can find another point. And we'll show you how we can find another point pretty easily. So what's nice about your course Compass is that you have graphing tools that help you graph in there. So what's the first thing you think that we could plot possibly from this line? What is the first thing you could knock out? Y-intercept. So once you see the number at the end, it tells you where it crosses the y-axis. Since it's a +3, I'm going to go up 3 on the y. So the first thing I do is I'll first plot the y-intercept. Then I'm going to find another point. So when I'm plotting a line, I first plot the y-intercept. Then I use slope to get another point. So what do I mean by that? I use slope to get another point. What does slope is -5 mean? What's the 2 R words that you're always taught with slope? Yep.
Rise over run.
Rise over run. You okay?
Sorry.
I don't know if you're sneezing in there. For some reason, when I wear a mask right away, it makes me sneeze first. Kind of tickles my nose and I start sneezing. So it means rise over run. It means the vertical change and the horizontal change. So if we see that the slope is -5, we could move where? How could we move?
Down 5.
Down 5. So very good that you do rise first. You do down 5. 1, 2, 3, 4, 5. So that puts us down at -2, but that's not a point because I still got to move over how far?
1.
1. So that puts us at another point at 1, -2. And then all you need are 2 points to draw a line. And you can draw your line there. Okay? All right. So any questions on how to kind of draw a line? Do I need to do another one or do you have it? Have you seen this before? Yeah. And like I said, we'll do more with lines in 2.1. This is just kind of like getting some of the basics out. Mainly, really, we're going to deal with slope. Now, make sure I want to stress a couple of things. If it asks me to describe the slope, like what does this mean? Usually they'll talk about X, then talk about Y. So if it says, what's the meaning of the slope? What does the slope mean? It means that for every 1 unit increase in X, because typically when we talk about stuff, we talk about X first, then we talk about Y. there is and we'll just answer this for this problem, there is a blank unit blank in Y. So, by how many units if does Y change? If X, we move 1 in X, how many units did the Y change? By 5. Now, did Y's increase? Did we increase or did we decrease? Decrease. So there is a 5-unit decrease in Y. So that's what the slope means. For every 1 unit you move in X, you go down 5 units. It's just a kind of a technical way to say that. It's like a little fill in the blank, you may get those activities. Just so you've seen one, you understand what we're talking about. And then we'll look at a real world problem here in a second that would describe that. So, now, how do we find slope? So what I mean by that is not just from the equation, but if I give you 2 points. So can I erase this? Is everybody just about good? I see squinting, so I better not. I can wait. Oh, you're okay. Can I erase? Are you all okay? Good news is it'll be on video. All right, we joke, we say when you can't fall asleep at night, you can watch one of these, and you'll fall asleep pretty fast. So, how do you find slope? So, I give you 2 points. Let's just say, check, I had a couple of answers I wanted us to give. Let's just say we have, our point 1 is negative 5.4, and our point 2 is 8, negative 4. So we have 2 points. We want to find slope. So what is the formula for slope? It's m equals, right? So what formula helps you calculate that rise and the run?
Y2 minus Y1 over X2 minus X1.
That's right. Y2 minus Y1 over X2 minus X1. We technically call that change in Y over change in X. Okay? So it's technically called change in Y over change in X. All right. So just a plug and crank. Just make sure you're consistent. Whichever point you call the second point, I mean, I went ahead and called it for you. Be consistent on, and then use the Y's and the X's in the proper place. And it's just really a plug and crank on finding that. Okay, so, Maria, when you're ready in a second, I'll point, you tell me what to write, okay? For slope. So what did you put for Y2? Minus Y1, which is 4, over X2, which is minus negative 5, right? So it becomes negative 8 over 13. That's it. There's your slope. Okay? Everybody good with that? On how we computed that? Any questions on finding slope? Yep.
So say it's something you can simplify. Do we need to put this simplest
Yes.
form?
If it's a fraction, they'll want you to put simplest form. All right. The other question I have is, how many different types of lines are there? How many different types of lines are there? I'll ask it this way. All right, yeah, let's see. Yeah, good. Well, no, that's different because that's a different function. That's absolute value. So just stick with linear function. Think about the different ways a line can go. I think you're thinking of really 2. There you go. There you go. Now we're getting somewhere. So if the line is like this, what's the slope? Positive. So one way is the line is oriented like this, where slope is positive. Very good. And the other way, and what what do we say the line is doing? Well, it's going up, but the technical word for going up is
Increasing.
increasing. Then you have the line like this, where the slope is always negative and the line is decreasing. So if the slope is negative, the line is decreasing. Now there's four ways, right? You were showing me the different one. What else is there? So there's four ways a line can be. We've got two of them. Horizontal. This is a horizontal line. Like that, and the slope is what? You know what the slope is? Zero, always slope. So this is your line, Sydney, that we looked at earlier. I would prefer that to be put up.
I'm trying to do this.
Yeah, well, here's the problem. You're gonna be asking me for questions on this because you're not paying attention. So what you need to do is you need to put that up and you would need to take notes. That would be amazing. Thank you. There you go. All right. So because you had a question earlier today, that's why I'm talking with you. You had a question on a horizontal line, right? And so now this is what we're discussing, is horizontal line. All right. So then what else? What's the last type?
Vertical.
Vertical. You know what the slope is for a vertical line? It won't be zero, so we'll look at that. So I'll draw a horizontal line, we'll see why its slope is zero, and then I'll draw a vertical line. And we'll see why its slope is not zero, it's something else. Let me erase this here. All right, so let's see. So let's just say we have the horizontal line that we had earlier, y is 3. Okay, y equals to 3. Let's see why the slope is 0. So I can see that this has the point 0, 3, and it has the point 2, 3. Those are 2 points on the line. So just go ahead and use your slope formula there to just write it out to get the slope. So here's your horizontal line. Find the slope, slope equals, and then I'm going to give you a vertical line, and let's just say it's over here at 4. So here's our vertical line, and let's just use, say, 4, -1, and 4, 3. So there's that. Okay, and then find the slope of this line. So we'll look at these two answers that you got, and then we'll kind of have an idea of what the slope is. So 0 on the top means one thing, 0 in the denominator means a different thing. So just making sure that we can write those. So, all right, Hank, when you go on the horizontal line to do slope, what do you write?
3 minus 3.
Yeah. Over.
2 minus 0.
So you get 0 over 2. So anytime you get a 0 in the top, in the numerator, it's just 0 is the answer. So 0 over a non-zero number, the answer is 0. And that's always going to work for horizontal lines because, see, the y's don't change. The y's are always the same on a horizontal line. So your slope is 0. So 0 over a non-zero number, the answer is 0. Okay? All right. So there's that answer on horizontal. So we can just say, oh, it's always going to be 0 for horizontal lines. Now look at vertical. So when I plug these in, doesn't matter. I was going to call this my second point, but it doesn't really matter. -1 minus 3 over 4 minus 4. So the top becomes what? -4. What do you get for the bottom?
0.
0. And when you can't divide by 0, so there's no answer. So what we just put is undefined. So instead of writing the whole word undefined out, you just put UND. So divide by 0 just means we write as undefined. Okay. All right, and those are the 4 types of lines. Okay. Increasing, decreasing, horizontal, and vertical. And there's slopes that go with it. Any questions on how to compute slope using the slope formula? Is everybody good with So we're gonna write our slope formula up here. Everybody good with that? Any questions about that? Okay. All right, I guess I just gotta erase here. Okay. All right, good. So next, all right, so a little real world problem here. We'll just call this one example 2. All right, so here's what we got. We've got yards of carpet. So a lot of times they'll measure fabric in yards. Anybody ever bought fabric before? Do they measure it in yards? Yeah, I'm just doing carpet. Yards of carpet, and then the cost in dollars. So this is the cost and the yards that you would purchase is linear. So I'm going to ask you a couple of questions. What's the slope? And what is the meaning of the slope? So can you figure out the slope? And then can you figure out the meaning of the slope? And I'll show you a little hint that I use to do it. So go ahead and figure out what the slope is, and then we'll talk about what's the meaning in terms of this problem. And on the real world problems, it's helpful if you put the units with your answer. Okay? It's helpful if you put the units with your slope, because then it helps you understand what's going on. If that makes sense. Okay. So what did you get, Paige, what did you get for this slope?
It might be wrong, but I don't know.
9/3, which you can reduce it to what? 3/1. All right, so you can see if you did 2 points here, that's the 0.3. It's actually 3 yards, $9, right? If you look at the units.
Yeah.
But you can see, since it starts from 0, 0, the slope is gonna be 9/3, changing y with changing x, which you get 3, and I think it helps if you put 3/1. And I think it actually helps if you put the units. So the top is the y's, right? Changing y. So the units would be what? Dollars. So if you put the units, $3 for the top, and then the bottom, you can leave the 1 for now, because I think it helps to have the fraction. What's the units for the x? Yards. So what do you think it means? 3. Yeah, so for every yard you buy, it's $3. $3 a yard. That's how they price it. Okay, so your real world answer is $3 per yard. So do you see? I think it's helpful if you put your units when you're writing this out. Okay. Any questions about that? Pretty simple. Okay. All right. Can I erase this? Very good. All right, one more problem, that's a real world problem, but this time it'll just be an equation. So let's just say I left the gas station, I'm driving in my car. I guess that was example two, call this example three. So driving in the car, and the equation would be distance in miles since gas station. All right. So, let's say the equation is this. And so your D is your distance in miles. And your X is your time driving in hours. Okay. All right, so first question. Do you see that that is what? What type of function is that? Linear, right? Linear function is the equation of a line. What's missing? What do we not see? Y-intercept. So what's the y-intercept? 0. All right. So a couple of questions. Can you find part A, find the distance traveled in 3 hours? All right. What is the slope? And what does it stand for in this problem? What does it represent? See if you know. Okay. All right, so see if you can answer that's basically 3 questions, right? Find the distance traveled in 3 hours, what is the slope, and what does it represent in terms of this problem? All right, so let's see, who can give us the distance traveled in 3 hours? What did you get? Anybody? 5?
No, oh, it's right to my.
Oh, okay. I'm sorry.
156.
Please tell me you didn't get 5. 156 sounds good, right? Plug and crank. So you plug your 3 in for X, you got the distance is 156. What would the units be for that?
Miles.
Miles, okay. What is the slope for this problem? 52. Now look, you can always do the units because it's always going to be the Y units over the X units. So the Y units, or in this case, D is the Y. What's the Y units? What's being measured? Miles. And what is the X units?
Gallon.
No, not gallons.
Time.
Time in what?
Hours.
Hours. Hours is a unit of time. So 52 miles hours, you don't say miles hours, we say what? 52? So what does that stand for? What is that? That's the speed of the car. And guess what? It's going 52 miles per hour. That's the speed. Okay. It's traveling at constant speed. So how can you travel at constant speed in a car? How can you travel at a constant 52 miles an hour?
Cruise control.
Cruise control. It's on cruise control. That's exactly right.
We're doing it on the interstate.
Yeah, it's hard to do on the interstate. We all get angry when we're in the left lane and we're on, I won't tell you what I have my cruise set at, but it doesn't start with a 7. and a car comes from the right lane into the left lane in front of us and goes 62 miles an hour. We all enjoy that, but it just happens. Okay. All right. You okay with the real world problems? All right. So, how do you know if something's not linear? So what's gonna be the sign that something's not linear? So earlier, when we talked about absolute value, even though it's two lines put together, technically it's not linear. Because it's not just one, it's not one of those four, either increasing, decreasing. What else would be something you can think of that's not linear? Just basic functions. X squares, so parabolas, that's not linear, right? What's another one?
I just said a circle.
The circle, so that equation is like x squared plus y squared, so circles are not linear. And what about an x cubed graph, right? That's like this. So basically, what are you noticing about the exponent on x?
It needs to be equal to 1.
Yeah, it's gotta be equal to 1 and then nothing else, nothing with the y and just a constant, okay? Even though that's 1, it's got the bars, which makes it not linear, even though it is two lines put together. So it's close though, right? So if we give you something like this, just say, hey, could you determine whether or not it's a line? And then if you know it's not a line, how could you plot this? So let's just say if I wanted to plot it, this was kind of our discussion the other day. How do you go about plotting something that's not a line? What do you do? Find points. So here's what I'm gonna do. If I'm gonna go and plot one of these, whatever it is, I'm gonna make a T-chart. And I usually pick 5 points. And the 5 points I pick are from x being -2, -1, 0, 1, 2. And then all I've got to do is plug in. So this is that practice you were getting in the last section where it said evaluate f. So that question that you asked me was evaluate. That's what they want you to do is plug in to get your points and then you can kind of plot it. So I think we can do this in our head. If I plug in, can you tell me what to write? So if I plug in a -2, what would you get? 4. Because square a negative, it's positive. Plug in a -1, what do you get? Plug in a 0.
0.
Plug in a 1.
1.
Plug in a 2.
4.
And then you could come up with a plot. And I think I just want to make sure that I'm tying this to what you work with. It has a parabola option. And then you could probably pick 0, 0, and maybe I pick the 2, 4 as another option. And I think you could go and basically plot the parabola for you, okay? I don't think that plot feature is too bad. All right, everybody good with that? The last thing, if I did this, I'm gonna point, you're gonna tell me the name of it. See if you know what the name is. What is that called?
Y-intercept.
What's that called?
X-intercept.
All right, so from this, could you give the slope? You already got the y-intercept, and then can you write the equation y equals mx plus b? Let's just do that real quick. Let's finish that off, and then we're done with the lesson for today. Is slope gonna be positive or negative?
Positive.
Positive. So what do we get for slope?
3 over 2x.
There's no x in slope.
No, sorry, it's 3 over 2.
Yeah, 3 over 2. Y-intercept we said was 3, and then it's just plug and crank. Once you figure those two out, you just plug them in. So then it's 3/2 x plus 3, you have the equation. I want to stop there. I think we're all right. Okay, this is not due until, I might even push it to Tuesday. I think it's due Monday night, but we'll do the next lesson on Monday. You guys have the AC